Right. In last class we seen how to write the recursive program and how to write the recurrence relation for that. Right. Now the thing which is pending in divide and conquer basics is recurrence relation solving how. Recursion you are okay. Recurrence relation also you are fine. Next one is going to be recurrence relation how to solve. Right. That is the topic now. Right. If you want you can see. See the recurrence relation solving. We have three methods: substitution method, recursive tree method and master theorem. These are the three ways to solve the recurrence relation. And one more thing. In the previous one, right, writing the recurrence relation and writing the recursive program, there I done one extra thing also. What is that? How to find out time complexity for recursive program, how to find out space complexity, right? Little bit I explained. Small doubt also there. In the previous, right, 4 examples. Right, recursive program, recurrence relation, 4 examples I given. Anyone having small doubt also, right, in the total divide and conquer, you will see that story only. Total divide and conquer, our goal is going to be writing recursive program, right, finding the time complexity, finding the space complexity. I given some rough idea in the previous 4 problem, little doubt also there, right. Definitely at the end of the divide and conquer chapter, you will get more clarity. See, always remember, starting will be little bit trouble. Right. So when after starting itself, if you stop, you may not grow. Right. Starting, definitely some trouble will be there. If I slap you first time, pain guarantee will come. Right. If I keep on slapping, right, even though pain is there, you may not feel that much. So what I want to say directly is, right, starting pain will be there. When I started any topic, right, guarantee some trouble will be there. Right. Because of that trouble, you cannot stop. Right. Please keep more hard work. Right, in the total divide and conquer chapter, those only will be there. Right, you please take care. From now onwards, careful. All the basics are going on. Right, after all basics are over, when an actual topic will start, right, automatically all your doubts one by one will be eliminated. Right, now see this. So recurrence relation solving, 3 methods are there. Substitution method. Now one more thing I want to say to you. Right, whatever happened until now, please don't think that much. Right, current topic, what is going on, please concentrate that only. Every day some problems will be there. Yesterday if you think some problems are happened, day before yesterday some more problems are happened. Right, if you keep on thinking them, right, you will lose this day. So whatever current topic is going on, please concentrate on that. Small doubts there in the previous classes, you can revise again, right, you can clarify. That is the meaning of learning any subject. Learning any subject is nothing but, when you study first time, some mistakes will happen. Second time, though, I think few will be eliminated. Few will come. Third time, like that, keep on repeat. Right? When you do more revisions, right, definitely you can rectify all the mistakes. So forget about all the previous things. Concentrate this only. Right? Concentrate this one. Now, in this class, our goal is going to be, right? In this class, our goal is going to be how to solve recurrence relation. This is only your goal. Think about this only. Recurrence relation solving, 3 methods: substitution method, recursive tree method, master theorem. Right? Let's go to the first one. Right? Substitution method, how? Right? I will explain. Substitution method is nothing but substituting the given function repeatedly until given function is removed. Right? If you want, I will write also. Let me write now. See this one. Substituting given function repeatedly. Substituting given function repeatedly until given function removed is known as substitution method. I am repeating once again. Substitution function is nothing but substituting the given function repeatedly until given function removed is known as substitution method. Right? If anyone having small doubt also, in the substitution method, minimum 10 problems I will say, minimum 10. Right, from first problem onwards, please concentrate. What is the advantage of substitution? What is the advantage of recurrence relation solving? What is the advantage? You will see that. Basics are going on. Recursion, you are little bit okay. Recurrence relation, that is also okay. Recurrence relation solving going on, right? Please be comfortable. All the basics, if you learn properly, further topics becomes very easy. Right, fine. So now see this one. Substitution method definition also I written, many times I repeated also. Substituting the given function repeatedly until given function removed is known as substitution method. Take the first problem. Take the first problem. Example 1. From now onwards, please be careful. Example 1. T of n is equal to, right? Recurrence relation, T of n is equal to 1 if n is equal to 1. T of n is equal to 1 if n is equal to 1. Otherwise T n minus 1 plus n if n greater than 1. It is the recurrence relation. This is the recurrence relation. How to solve, right? I will explain now. Please be careful, right? The purpose of this class, again I am repeating, the purpose of this class is going to be, recurrence relation solving how. And one more, algorithm subject don't study whatever way you want. You study like topic wise. Don't say algorithm subject I am not comfortable. I used to say this story again and again in every class also. Don't study this subject whatever way you want. Study this subject topic wise. What is the meaning? Right? So recurrence relation solving one topic. Next one is going to be, right? Time complexity finding one topic. Asymptotic notation one topic. Topic wise you study. If you want to ask your friend, right, some help and all, you have to say in the topic number this, right? Problem number 4. I have some small doubt, please explain. Don't say explain algorithm subject. Ask him, right? In the topic number 5, problem number 3, I have doubt, please explain. If you do that, everyone try to help you. If you do some, right, some blind statement, explain algorithm, explain gate syllabus, people may not help you. Because of this reason, normally friendship will die. Right? Please be careful. Topic wise you study. Your goal this only. This topic as of now going on. Whenever algorithm subject is over, totally maybe 30 topics are there. Please try to give importance to topic wise. In every topic some problems are there. Please go. Right? When you read all the 30 topics, right? In few topics maybe, few problems will trouble you. You can take your friend help. You can keep on read again and again by yourself. You can ask me also. You can Google it out also. You can see in the YouTube also. Try to do as much as possible from your side. Afterwards, you can take, right, someone help, because we all are living in a society. Everyone ready to help you when you do really nice work. If you do really nice work, many people are there to support you. If you are not doing really nice work, many people may not support. Even friends also don't support you when they got to know you are not doing enough work. Right? It is the first problem. I am repeating again. Topic wise you study. Current topic going on is recurrence relation solving how, which internally contain 30 problems maybe. Recurrence relation solving how, right? 30 problems maybe I will cover. Substitution method, few problems. Recursive tree method, few more problems. Master theorem, few more problems. Right? The purpose of this topic is going to be how to solve recurrence relation. This is the starting one. One recurrence relation is given. Using substitution method, how to solve, I will explain. Right? See the recurrence relation. Tn is equal to 1 if n is equal to 1. Otherwise, Tn minus 1 plus n. Every recurrence relation or recursive program contain two parts. Right? Termination condition and continuing further. And one more thing. Every recurrence relation contains two parts, termination condition and continuing further. It's okay. Right? Who is the major one? Major one is termination condition or continuing further. This is the major one. Continuing further. Recursion is the major one. See, T calling T. Your function name is T. T calling T. This is called recursion. This is the major one. Please be careful. It is the major one. Stopping purpose is this is there. T calling T, this is going to be recursion, which is the major one. In every recursive program, major part is else part, which is nothing but a recursion. This is the major part. This is only for stopping purpose. If it is not there, program may repeat many times. Stack overflow error message may come. Right? That is the reason every recursive program should have termination condition. Right? So next one. This is the major part. Please be careful. Our concentration is this only. Second part only. First part for stopping purpose, it's okay. See read the second part. Read the second part. Tn is equal to Tn minus 1 plus n. This is the major one, right? If you are okay with that, Tn is equal to Tn minus 1 plus n, if you are okay, you only say, what is the T10? T10 is equal to T9 plus 10. Please try to understand this, right? Recurrence relation, if you want to solve, before going to solve, please by using numbers, what is going on, verify. Our part is second one only important, this one important, right? Please, until you are comfortable, before going to solve any recurrence relation, until you are comfortable, please substitute numbers and check. Can you help me now? T10 is equal to T9 plus 10. Next one, T100 is equal to T99 plus 100. Lastly, let me ask you, T2 is equal to T1 plus 2. T2, T of 2 is equal to T1 plus 2. Right? Please be careful. If you are comfortable, I am starting now. See this one. If you are comfortable, I am starting now. See this. So let me solve this problem. I think everything fine. Second part only important. I am writing the second part. See this one. Tn is equal to Tn minus 1 plus n. Right? Second part only important I written. This is only for stopping purpose. First point is only for stopping purpose. Right? Second one, see. Tn is equal to Tn minus 1 plus n. Everyone know. Now can you help me now? Tn is equal to Tn minus 1 plus n. It's okay. What about T10? T10 is equal to T9 plus 10. What about T100? T99 plus 100. If you are okay. What is the meaning of substitution method? Substituting the given function. What is the given function? T. Substituting the given function repeatedly until given function removed. What is the meaning? This function I have to substitute. Can you help me now? Tn is equal to Tn minus 1 plus n. What is the Tn minus 1? What is the answer? Tn minus 1 is equal to Tn minus 2 plus n minus 1. Because of this one is given. This one, whatever is there previously, same. Right? Fine. Substituting the given function repeatedly, right, until given function removed is known as substitution method. So, Tn is equal to Tn minus 1 plus n. It is okay. Then, Tn minus 1 is equal to Tn minus 2 plus n minus 1. Everyone fine. Right? I think see this one. It is the first time substitution. It is the second time substitution. Please be careful. In the similar way. First time, this itself is first time substitution. If you replace this one by this, second time substitution is over. Let me do one more time substitution. Function only matters. See, T calling T. Function only our goal. This function let me expand now. Tn minus 2 is equal to what is the answer? T n minus 3 plus n minus 2. Right? For this is plus. Remaining things are as it is. N minus 1 plus n. Right? Like this. 3 times I substituted. See, so it is the first time. Whatever is given, that is the first time. This is the second time. This is the third time. 3 times I substituted. And one more. When you substitute 3 times, right? 3 non-recursive term came. See, first non-recursive term, it is the second non-recursive term, it is the third non-recursive, it is the recursive term. Every time one non-recursive term. See, first time, first non-recursive term, second time, second non-recursive term, third time, third non-recursive term came. Now, from now onwards, if anyone asks you, whenever substitution method is going on, how many times I have to substitute? What is the answer? You have to substitute 3 times first. Right? Substitute 3 times. Substitute the given function 3 times you do. Every time one non-recursive term will come. Right? 3 times I done. Please be careful. 3 times I done. Don't do more number of time. Don't do less number of time. Do 3 times. Substituting the given function repeatedly until given function removed is known as substitution method. Substitute 3 times first. Yes, I substituted 3 times. When you do 3 times, 3 non-recursive terms came. See, it is the first non-recursive term, it is the second non-recursive term, it is the third non-recursive term. 3 times if you do, you got the 3 non-recursive term. Please be careful. And one more thing. After 3 times substitution is completed, let's check what is going on. After 3 times substitution is completed, let's see what is going on. What is going on? Let me check. Can you help me now? If I do 3 times, I got n minus 3. Right? If I do 3 times, I got n minus 3. If I do 2 times, n minus 2. If I do 1 time, n minus 1. Please be careful. If I do 3 times, n minus 3 I got, it's okay. But what about before? N minus 2. What about before? N minus 1. What about before? N minus 0. Like that. If you do 3 times, everything going on in terms of 3 only. If you do 3 times, everything going on in terms of 3 only. 3 times I done, I got 3. It is the 3 means it is the 2. It is the 2 means it is the 1. It is the 1 means 0. Can you help me after 3 times over in the substitution method? What will you do? Please analyze what is going on. This is a very, very crucial step. After 3 times over, please check what is going on. One thing is confirmed, right? Because of 3 times you done, everything going on in terms of 3 only. So in terms of 3, it is the 3, it is the 2, it is the 1, it is the 0. Some people are asking 3 times I done, everything is going on in terms of 3, that is okay. Then if it is the case, 2 times if you do, everything should go in terms of 2. Let me check. 2 times if I do 2 I got, it is the 2 means it is the 1, it is the 1 means 0. If I do 1 time, everything is in terms of 1, it is the 1, it is 0. Fine. That is true, right? In every problem, this is the model. Substitute. If anyone asks you, apply substitution method for this given recurrence relation. What is the answer? 3 times you do. After 3 times over, please analyze what is going on, right? Whatever you are analyzing, that is working fine for the third one. Check same thing happening for 2 or not. Same thing working for 1 or not, please verify. After everything is comfortable to you, after everything is fine, then what will you do is, right? What will you do is, see this one, do this one k time. Do this one k time. Can you help me now? 3 times if I do, this is the story. 2 times if I do, this is the story. If I do k time, what is the answer? If I do k time, t n minus k. If I do k time, t n minus k. Can you help me now? If it is t n minus k, what about this one? What is the answer? N minus. What is the answer? N minus k minus 1. 1 less. Please check. See this one. It is the 3 means it is the 2. It is the 2 means it is the 1. In the similar way, it is the k means it is the k minus 1. What is the next one? N minus k minus 2. Continue like this one. What is the last one? N minus 0, like this. If you are okay with the 3 times, you are okay with the k times. Some people are asking, if I do 3 times, I got n minus 3. If I do k times, I will get n minus k. Right? This is the n minus k. All will be in terms of n minus k only. Right? I think here, what is the answer? Here n minus k. It is going to be 1 less, and so on. Right? Fine. If you are really okay, some people are asking, sir, why you done k time? What is the k value? Let me check this one. Right? Can you help me? What is the recurrence relation? Tn is equal to 1 if n is equal to 1. If this is 1, n is equal to 1, then answer is 1. Let me check. I substituted k time. If I do k time, I got this one. Right? But one thing, I have to continue until, right, until this function is removed. This function is removed. If you want to remove this function, right, you continue to k time, it's okay. If you want to remove this function, it should be 1. Let me check here. N minus k should be 1. After doing k time, I got n minus k, but this value I want 1, right? Then only I can stop. That is the termination condition. This value should be 1. N minus k is equal to 1. Then finally, what is the answer? N minus 1 is equal to k. 1 will come this side, k will go that side. K becomes n minus 1. Right? Replace k by n minus 1. K times I done, some people are asking, k times you done, it's okay. But what is the k value? K value n minus 1. Then only I can stop. Let me replace k value n minus 1. T n minus of k is n minus 1. Right? This one, what is the answer? N minus of, right? K is n minus 1 there. Right? Next one, n minus of n minus 2. Right? It is the n minus 1. It is going to be n minus 1 minus 2. It is going to be n minus 3. Right? It will continue like this. Lastly, right? N is there. Now, let's see. What is the story here? I think n cancel, minus 1 plus 1 becomes 1. It will become t1. Next one, n cancel, it's going to be minus of minus 2 is becomes 2. Next one, 3. Next one, 4. And so on. Lastly, n. Next one, what is the t1? See the termination condition. What is the t1? T1, right? Tn is equal to 1 if n is equal to 1. If n is equal to 1, t1 is equal to 1. Right? Let me keep there. It is the 1. 1 plus 2 plus 3 and so on, n. Right? Try to remember this entire thing is Tn. This entire thing is Tn. Tn is equal to this one. Right? If I solve this one, finally I got this one. Which will goes to n into n plus 1 by 2, sum of n natural number. Right? So if you forget about small thing. Right? Can you help me one small line now? This is Tn. What is the Tn exact answer? Tn exact answer is this. Tn exact answer is this. Please be careful. Tn is this much. Right? Can you help me now? If this much, right? This can be written as big O of n square. You check. Right? What is the meaning? Left side, n into n plus 1 by 2 is there. I written the upper amount big O of n square. That is fine. Right? Can you help me? What is the left side there? Left side Tn is there this much. This is big O of n square. What is the reason here? N square by 2. Here simply n square. I think right hand side is bigger. And one more thing, left side, right side, bigger function same. Left side is n into n plus 1 by 2, right side is n square. Left side, right side, both the bigger functions are same. You can write theta also. Omega of n square also you can write. Finally, theta of n square also you can write. That is the reason in some books theta of n square. Theta is there means big O is there, omega there, because left side, right side same. The purpose of this entire thing is going to be how to solve recurrence relation using substitution method. Using substitution method, this is the way of recurrence relation solving. Some people are asking, sir, if I give second problem, how I will do? What is the answer? Before starting to solve that recurrence relation, what is the first step you will do is, right? So concentrate on else part, not if part. Before solving any recurrence relation, concentrate only else part, not if part. Next one, after concentrating by substituting different numbers, please be comfortable. T10 is equal to T9 plus 10, whatever way I am comfortable initially to this problem. Same way, if any new problem is given, do like that. Please be comfortable else part by substituting numerical number. Suppose if you are comfortable that also, then what will you do is substitute 3 times first like this. Right? 1, 2, 3. Substitute 3 times. After 3 times completed, right? What is going on? Please verify in the third step. Because of 3 times you done, answer is right. Definitely everything is there in terms of 3. You only say you done 3 times, definitely some relation will be there with the 3. Please verify. But when you got to know some relation going on, if you do 3 times in terms of 3, some relation going on, same thing will work out for 2 also. 2 times if you do, some relation should going on in terms of 2. Please verify. 1 time also, after verification everything is completed. Just go k times. What is the k value? Afterwards we will see. Just go k time, in terms of k, all will come. Right? Finally, what is the k value so that this function will become termination condition? Right? I think this value is equal to termination condition. So k value find out, substitute the k value. After substituting, you will get one series like this. It is the sum of n natural number square formula series, right? So I done that. So actual answer is n into n plus 1 by 2. To this upper bound is n square, lower bound also n square, because of bigger, right? Upper bound, lower bound both are same. Then you can write theta. So to this problem, right? This recurrence relation, if you solve, you will get the finally answer as n square. Answer is n square. Can you help me? What is the actual answer of this problem? N into n plus 1 by 2. What is the upper bound? Big O of n square. Lower bound, omega of n square. Big O, upper bound, both possible, theta also. Right? To this problem, answer is going to be theta of n square, which is nothing but big O of n square possible, omega of n square is possible. This is the way how to solve recurrence relation using substitution method. Anyone having any doubt, right? Almost like 10 problems are there. Right? I'm thinking you are little bit okay. If small doubts also there, in the next problem you can see now. Right? Fine. Let's go to the next problem. Yeah, let's go to the next problem. Example 2. Tn is equal to 1 if n is equal to 1. Otherwise t n minus 1 into n if n greater than 1. Some recurrence relation like this. But the second problem. Tn is equal to 1 if n is equal to 1. Otherwise Tn minus 1 into n if n is greater than 1. Any recurrence relation is given. If you want to solve this one using substitution method, right? Let's concentrate only second part, right? It is the if part, it is the else part. Else part concentrate. This only our goal. This only. Read it. Tn is equal to Tn minus 1 into n. Right? If you are okay with that, by substituting different numbers, please verify. Can you say what is the T10? T10 is equal to T9 into 10. What about T100? T100 is equal to T99 into 100. Last one, what is the T2? T2 is equal to T1 into 2. If you are really okay, if you are comfortable, then start the actual story. Right? What is the actual story? 3 times you have to substitute. Let me substitute. Tn is equal to Tn minus 1 into n. Tn is equal to Tn minus 1 into n. Now substitute this. Right? Tn is equal to T. Recursive function only our goal, not non-recursive function. T calling T. Right? So Tn is equal to Tn minus 1 into n. That's fine. What is the Tn minus 1? Tn minus 2 into n minus 1. This is for Tn minus 1. Right? Into n, that is as it is. right? Previously whatever there, same thing will come. Recursive function, you are substituting, this one is came. 2 times substitution is over. If anyone still troubling, right? Let's see the third one. Third time. Recursive function only your goal. Remaining things as it is will come. Tn minus 2 is equal to Tn minus 3 into n minus 2. This is as it is into remaining things are as it is n minus 1 into n. So 3 times I substituted. Right? Remaining things are as it is. That's okay. So can you help in how many times you substituted? You substituted 3 times. If you substitute 3 times, if you want you can check. 3 non-recursive terms came. If you substitute 2 times, 2 non-recursive terms came. If you substitute 1 time, 1 non-recursive term. So why it is non-recursive term? T not there. Here also T not there. Here. These are non-recursive terms. 3 times I substituted. 3 non-recursive terms I got. 2 times 2 non-recursive terms. 1 time 1 non-recursive term. Like that came. Now can you help 3 times you have to substitute. I done. What is the next step? 3 times substitution you do? Yes, I done. What is the next step? After doing 3 times, right? In the last step, please be careful. 3 times you are done. Definitely, all will be in terms of 3 only. All will be in terms of 3 only. 3 times if you do, compulsory, all will be in terms of 3 only. Let me check, all are in terms of 3 or not. Let me check. Let me check here. 3 times if you do, you got 3 here. It is the 3 means, it is the 3 means it is the 2. It is the 2 means it is the 1. It is the 1 means it is the 0. 3 times if I do, all will be in terms of 3. That's okay. If at all it is right or wrong, to verify, just check the 2 also. If you do 2 times, all will be in terms of 2. It is the 2 means it is the 1. It is the 1 means 0. Right? Suppose if at all, if you do 1 time, all will be in terms of 1 only. It is the 1 means it is the 0. Like that it is happening. I'm thinking that everything is okay because of you are comfortable. 3 times what is going on, 2 times what is going, you are really comfortable. Do like this one k time. If you do k time, what is the answer? If you do k time, let me check here. T n minus k will come. 3 times means n minus 3. Right? K times means n minus k. Right? What about this one? Right? N minus half. What is the answer? It is the k means. It is the 3 means. It is the 3 means it is the 2. It is the k means it is the k minus 1. Right? Let me write now. Right? It is going to be k minus 1. Right? It is going to be, right, k minus 2. Right? And so on. What is the lastly? N is there. Right? Now some people are asking everything is okay. See this one. It is the k means it is the k minus 1. It is the k minus 1 means k minus 2 and so on. Lastly N, it's okay. Now some people are asking me what is the k value. Let me check this one. Right? So what is the meaning of substitution method? Substitute until given function removed. What is the meaning? This should be removed. This total one, T of n minus k should be removed. Can you say what is the termination condition? Right? N, right, this one, Tn is equal to 1. Tn is equal to 1 means T not there here. Means removed. Tn is equal to answer is 1. If n is equal to 1, what is the meaning? This value should be 1. Let me check here. N minus k should be 1. So finally, n minus 1 is equal to k. K is n minus 1. Substitute. So T n minus, what is the k? N minus 1. Into n minus, right, n minus 1 minus 1, right, next one n minus, right, n minus 1 minus 2 already there. It will continue until n, right. Now if you are really comfortable, cancel all the thing, n minus n cancel, t1 here. What is the next one? I think n cancel, 2 here, 3 here, 4 here and so on. Lastly n is there. What is the t1? You know, termination condition t1. What is the answer? T1 is equal to 1 if n is equal to 1. True. Right? What is the answer? This is 1. 1 into 2 into 3 into and so on. Right? N. Can you say what is this entire story? It is the Tn. Tn is this much. Now from now onwards, if anyone asks you to this problem, what is the Tn? What will you say? Tn is equal to 1 into 2 into 3 into and so on, and which is nothing but n factorial. Tn is n factorial. From now onwards, if anyone asks you to this problem, what is the Tn? What will you say? N factorial. Tn is n factorial. Can you help me now? This n factorial is the upper bound or lower bound or exact? Exact. What is the reason? There is no big O until now. There is no omega. There is no theta. Tn is n factorial. It is the exact answer. It is the exact answer. If anyone asks you to this problem, what is the answer? What is the actual answer? N factorial. Please see the option. In the option n factorial is there. You select. If n factorial not there, its upper bound may be there, its lower bound. Whenever actual not there, upper bound may be there or lower bound may be there. Can you say what is the n factorial upper bound? N power n, everyone know. N factorial upper bound, immediate upper bound I written n power n, you know very well. Can you say n factorial lower bound? What is the answer? Right, 2 power n. Comparing n factorial and 2 power n factorial is bigger. This is the omega, this is the big O. Because of, right, because of big O omega not equal. Immediate things I written. Immediate things I written, big O omega not right, not equal. That is the reason. So what is the answer now? Theta not possible. N factorial is big O of n power n, this one. Comparing this one, this is a little bit bigger. Comparing these two, this is a little bit bigger, right? Comparing these two, n factorial is a little bit bigger. Comparing these two, n power n is a little bit bigger. Anyhow, can you help me now? When will you go for upper bound, lower bound? What is the answer? Actual answer not there. You go upper bound or lower bound. See this one. Until now, until here, same. Solving recurrence relation until here. Until here, solving recurrence relation. After solving recurrence relation is over, you got answer as n factorial. If n factorial there in the option, you select it. If not there, its upper bound may be there. Its lower bound may be there. Please be careful. Right? Whenever equal is not there, then go for upper bound, then go for lower bound. Can you help me how to solve the problem? How to solve any recurrence relation using substitution method? What is the answer? Do 3 times. After 3 times over, please check in the last step. 3 times over. In the third step, please check. Everything is in terms of 3 or not. If at all everything is in terms of 3, check same thing working for 2 or not. Same thing working for 1 or not. Suppose the 3 working, what you are thinking, 2 not working, then I think something wrong. So again I am repeating. Do 3 times. After 3 times over, third step answer please verify all are in terms of 3 or not. If at all are in terms of 3 there, right, I think almost fine. Is it for confirmation purpose? Check all are in terms of 2 also in the second line. All are in terms of 1 also in the first line. If at all are working as you are thinking, right, then go for k time. Find the k value like this. Find the k value like this. Right, after finding k value, substitute, you will get the one series. Right, solve that series. This series value is going to be n factorial. After getting the actual answer, please see the option. In the option it is there, select it. If not there, its upper bound may be there, its lower bound may be there. This is the second problem, right? First problem, second problem you got means almost you are comfortable with substitution method. What is the substitution method behavior? Substitute the given function repeatedly until given function removed. Can you say where is the given function removed? Here. Here given function removed. When the given function removed, termination condition will come. Then given function removed. See this one. I think t1 replaced by 1. Here removed. Substitute the given function repeatedly until given function removed is known as substitution method. When will you go for upper bound, lower bound? Actual answer not available. Then go for upper bound, lower bound. I am thinking that you are absolutely fine. Let's go to the next problem. See the next problem. Example 3. Example 3. Let me check. Tn is equal to, example 3. Tn is equal to, answer is 1 if n is equal to 1. Otherwise t n minus 1 plus 1 by n if n greater than 1. This is one more recurrence relation we have to solve it. Tn is equal to 1 if n is equal to 1. Otherwise Tn is equal to Tn minus 1 plus 1 by n. And one more, right? This recurrence relation I am solving, please be careful. If part, else part, which is important? Else part only, this only. Tn is equal to Tn minus 1 plus 1 by n. This only more important to us, right? Now can you help me? Because of else part only important, read it. Tn is equal to Tn minus 1 plus 1 by n. If you are really comfortable with this, before starting to substitute, right, please verify in terms of numerical value. Let me substitute. T10 is equal to T9 plus 1 by 10. Next one, T5 is equal to T4 plus 1 by 5. Lastly, T2 is equal to T1 plus 1 by 2. Right? If you are comfortable, let me substitute. If you are comfortable, let me substitute. Tn is equal to, what is the answer? T n minus 1 plus 1 by n. Tn is equal to Tn minus 1 plus 1 by n. I think one time substitution is over. Let's substitute second time. What is the answer? T n minus 2 plus 1 by n minus 1. Right? Tn is equal to Tn minus 1 plus 1 by n. That is if it is okay. Tn minus 1 is equal to Tn minus 2 plus 1 by n minus 1. Already 1 by n is there. Right? Because of this is k. This is as it is. Next one, let's go once again here. Tn minus 2. What is the answer? Tn minus 3 plus 1 by n minus 2. Right? Remaining things are as it is. 1 by n minus 1 plus 1 by n. Right? I think if I do 3 times, this is the story. Some people are asking, after 3 times over, what I have to do? Right? Everything is there in terms of 3 or not. Let me verify. Can you help? If I do 3 times, this is the 3. It is the 3 means it is the 2. It is the 2 means it is the 1. It is the 1 means it is the 0. I think everything is in terms of 3. For a verification purpose, try here also. If you do 2 times, it is the 2. It is the 2 means it is the 1. It is the 1 means it is the 0. If you do 1 time, this is the 1. This is going to be 0, like that. Right? Because of everything you are comfortable. Let me do like this one, k time. If I do k times, what is the answer? T n minus k plus 1 by n minus k minus 1 plus 1 by n minus k minus 2 and so on. It will continue. What is the last one? 1 by n. Next one, let me find out k value. What is the answer? What is the termination here? That is also same thing. What is the answer? N minus k is equal to 1. N minus 1 is equal to k. K is n minus 1. Right? Let me write now. This is going to be T of, right? Replace k by n minus 1. This will become n minus of n minus 1. Right? This one become 1 by n minus of n minus 1 minus 1. 1 by n minus of n minus of minus 2. It will continue until lastly 1 by n. Right, let's simplify. This will become what is the answer? T of 1, this is everyone now. Can you say what about this one? N cancel. 1 by 2 here, 1 by 3 here, 1 by 4 here, and so on. Lastly 1 by n here. What is the T of 1? 1. So 1 by 1 plus 1 by 2 plus 1 by 3 plus and so on. 1 by n. Right, which will goes to, what is the answer? Every one of this is the series. 1 by 1 plus 1 by 2 plus 1 by 3. Try to remember, right? So Tn actual answer is this. Tn actual answer is this, right? If it is there in the option exactly like that, right? Please go ahead. If not there, try to remember this is the series of log n series. So answer is going to be, right, order of log n. This is the log n series. Please be careful. Tn is equal to approximately log n series. Both are asymptotically equal. Tn is equal to 1 by 1 plus 1 by 2 plus and so on 1 by n. Both are asymptotically equal. Tn is approximately equal to big O of log n. If you want, you can keep theta also. This is the answer for this. The purpose of this problem to say this series. I want to say this series. This series is approximately equal to log n. To say the purpose of this problem, substitution method, it's okay. I want to say this series. Right, it is already, whenever I am saying time complexity, that time also I said to you, this is the log n series, right? This is approximately equal to log n, right? Big O also okay, omega also okay, theta also okay. See this one, when both are equal, this series is equal to this one. It is not upper bound, it is not lower bound, right? Both are, right, approximately equal. Constant factor may be differ, both are approximately equal. Theta also you can write. Finally, I want to say to you, this is equal to, right, log n series, right? Same. So 3 problems I completed for substitution method, right? Few more problems are there. Let's go to the next problem. Example 4. See this also. Example 4. Tn is equal to. Example 4. Tn is equal to. Tn is equal to. Right? Answer is 2. Tn is equal to 2. If n is equal to 0. Tn is equal to 2 if, right, if n is equal to 0. Next one, T n minus 2 plus log n base 2 if n greater than 0. Tn is equal to 2 if n is equal to 0. Tn is equal to Tn minus 2 plus log n base 2 if n is greater than 0. It is a given problem. This problem how to solve, we'll see now. And one more, can you help, if you want to apply substitution method, what is the first step? See only else part. See only else part. Read the else part only. Tn is equal to Tn minus 2 plus log n base 2. Right? If you are okay with the else part, can you substitute the numbers and verify? Verify now. Substitute the number. T10 is equal to T8 plus log 10. T100 is equal to T98 plus log 100 base 2. Lastly, T2 is equal to T0 plus, right, log 2 base 2. If you are okay, let's do the substitution method. Let's start. I am saying to all are same. That is the problem with any method. Any method advantage is going to be all will follow same story. Substitution method, name itself is substitution method. It is having some procedure. In that procedure, if you are okay with using that procedure, 2 or 3 problems, if you are comfortable, everyone will follow same story. Right? Let's see this problem also. Right? So let me start here. Let me start. What is the answer? Tn is equal to Tn minus 2 plus log n. Let me write. Tn is equal to Tn minus 2 plus log n base 2. Tn is equal to Tn minus 2 plus log n base 2. Right? It is a given recurrence relation. Let's substitute further. What is the Tn minus 2? What is the answer? Tn minus 4 plus log, see this one, n is there, minus 2 here, log n minus 2 there, n minus 4, log n minus 2, base 2. Plus already whatever log n base 2 there, same thing. Because of this one is came, remaining thing as it is. What is the Tn minus 4? Tn minus 6 plus log n minus 4 base 2. Plus remaining things are as it is, log n base 2. Right? So if you do 3 times, this is story. If you do 3 times, this is the story. Now some people are asking, after 3 times over, what we have to do? What is the answer? After 3 times over, what you have to do is, right? So please see what is going on, right? Please see, third step is in terms of 3 or not, verify. Verify third step in terms of 3 or not. It is an interesting thing. After 3 times substitution is over, please verify third step is in terms of 3 or not. Let me check. It should be, I am not saying 3. After 3 steps are over, in the third step, please verify. In the third step, everything is in terms of 3 or not. I am not saying is it 3 or not, in terms of 3 or not. Right? I am verifying. See, so I am verifying. How to verify? 3 times I done. In the third step, everything should be there in terms of 3. How it is? Let me check. How it is? Can you help me now? 3 times you done, it is a 6. Actually, I expected in terms of 3. Right? It is a 6. How? Nothing there. 2 into 3, 6. 3 times you done. And one more. Why 2 into? Right? Because of every time double you are subtracting. See, first time 2 subtracted. Second time, right? 4 subtracted. Third time 6 subtracted. What does it mean? Every time 2 subtracting. So double came. 3 times you done, 6 came. 2 into 3. 2 times you done, 2 into 2, 4 came. 1 times you done. What is the answer? 2 into 1. 1 times you done, but you got double. Why? Every time you are subtracting double. That is the reason. 3 times I done in terms of 3. 2 into 3. And one more. It is the 6 means it is the 4. What is the answer? Whatever is there, I think here minus 1. Minus 2. Let me write now. It is going to be 2 into 3 minus 2. So this is the answer. Next one. What about this one? Oh, let me check this one. Right? It is the 2 into, it is the 6 means it is the 4. It is the 4 means it is the 2. What is the answer? It is going to be 2 into 3 minus 4. Same, it will continue like this one and so on. Right? So if you do 3 times, everything should be in terms of 3. If you want, you can just say 2 into 3 here, 2 into 3 minus 2, 2 into 3 minus 4, 2 into 3 minus 6 and so on until n will come. This is a 0. That is okay. Right? Fine. So if you do 3 times, this is a story. If you do 2 times, let me check. It's the 2 into 2. It is going to be 2 into 2 minus 2. Right? Same thing will continue. Next one. If you do 1 time, 2 into 1. What is the next one? 2 into 1 minus 2. I think what is the answer? N minus 0. 0 okay. It is going to be 2 into 1 minus 2. Right? Like that. Everything is in terms of 3 only. If you go third step, everything is in terms of 3. If you go second step, everything is in terms of 2. If you go first step, everything is in terms of 1. If you are really comfortable, go k time. Go k time. Then what is the answer? If you go k time, what will happen? Let's check. T of n minus, what is the answer? If you do 3 times, 2 into 3. If you do k time, what is the answer? 2 into k. Right? Double came. Because every time 2 subtracting, k times you done, double came. Next one. What about this one? Log of, what is the answer? N minus 2 into k minus 2. Next one. Log of n minus 2 into k minus 4. Right? It will continue. right? Next one, if you do k time, that is story. If you do k time, that is story. Now let's check here. What is the k value? So what is the answer? N minus 2k. This value should be equal to termination. What is the termination? 0. Tn is equal to 2. Tn is equal to 2 is the answer. If n is 0, n is 0 means what? T0. I want 0. T0 is equal to 2. So this is 0. Right? N minus 2k is equal to 0. So n is equal to 2k. So k is equal to n by 2. K is equal to n by 2. Please be careful. Replace k by n by 2. Substitute now. It will become t of 0. This will become log 2. This will become log 4. This will become log 6 base 2 and so on. 2 difference. Lastly, what is the answer? Log n base 2. Right? This will become, what is the answer? It is the 2 plus t of 0 is 2. See the termination. It is going to be log 2 base 2, log 4 base 2, log 6 base 2. What is the last one? Log n base 2. Log n base 2. I am thinking everything is fine now, right? Let's go to the next one. Right? Next one, can you help me? 2 plus log 2 base 2, log 4 base 2, log 6 base 2 and so on, log n base 2. How to solve this problem? Right? In this problem, our goal is going to be how to solve this series. Can you read the series? Log 2 base 2. This series how to solve? This series how to solve? That is our goal. In every problem, one series will come. Right? Just to do 3 times. 3 times you done. Afterwards, go k time. Find the k value. Substitute k value. You got this series. Log 2 base 2, log 4 base 2, log 2, log 4, log 6 and so on, log n. All even numbers. Log 2, log 4, log 6, I think it is looking, because 2 difference, all even numbers. All even numbers. I think let's see this one. Because of even number. Listen everyone now. Because of even number, let's carefully listen. Because of everyone is an even number, you can write like this one. See, forget about base 2, 1, it's okay. See this one, everyone is even number. So you can write like this one, 2 into 1. Next one, log 4, 2 into 2. Log 6, 2 into 3. Because of everyone is even number. Right? Lastly, what is the answer? Log 2 into n by 2. Log 2 into n by 2. Next one, this can be written as 2 plus. Can you help me now? I think because of everyone is even number. Every even number can be written as 2 into something. I written. Now what is the answer? It is the log mn formula. Log mn is equal to log m plus log n. Right? What is the answer? Log 2 plus log 1. Right? From this. Same way here. Log 2 plus log 2. Same thing here. Next one. Log 2 plus log 3. Same thing here. It will continue like this one. What is the last one? Log 2 plus log n by 2. Next one, 2 plus. Now can you help me now? What is the answer? Can you help me now? I think everyone is even numbers only. If at total terms may be n, but only even terms. What is the answer? N by 2. See this one, n by 2 terms. Right? See this one, 1, 2, 3 and so on, n by 2. Even numbers, odd numbers, all there n. Only even numbers are there, only half. Right? But one thing is true. Every term given 2 values. Because log mn formula. Right? Now can you help me? How many terms are there? How many terms are there? N by 2 terms are there. Every term is given 2. I think total may be n terms in this. But one thing is true. In all these terms, if you observe clearly, what is the answer? Log 2. Log 2 common. How many times? N by 2 times. Let me write now. N by 2 times. Log 2 base 2. Remaining all if you observe. What is the remaining? This one. Remaining all. Let me write here. Log 1, log 2, log 3 and so on. Log n by 2. Right? This will goes to. 2 plus n by 2. Log 2 base 2, 1. So n by 2. Right? Plus. It is not into. Please be careful. It is into. It is going to be plus. Please be careful. It is not into. It is a plus. Because everywhere log 2 there. So log 2 n by 2 times. Already we done. Plus remaining. Right? That one. Plus. So this entire series we have to write. Log 1 plus log 2 plus log 3 and so on log n by 2. This can be written as a log of 1 into 2 into 3 into and so on n by 2. Right? This can be written as 2 plus n by 2 plus. What is the answer? This can be written as log 1, log 2, log 3 and so on log n by 2. This is nothing but what is the answer? Log of n by 2 factorial. right, which can be written as 2 plus n by 2 plus, what is the answer? This can be written as, what is the answer? Log of every one now. Log n factorial is going to be, right, log n factorial is going to be, upper bound is going to be log n power n. N by 2, see, n factorial is, upper bound is n power n, right, n by 2 factorial. What is the answer? Log n by 2 whole power n by 2. Upper bound I written. N factorial upper bound is n by 2 whole power n by 2. This can be written as 2 plus n by 2 plus, what is the answer? N by 2 log n by 2. Right? This can be, I think it is n by 2 into log n by 2. It is only n by 2. So forget about small constant. This can be written as big O of n log n. Right? Big O of n log n. Right? Please be careful. And one more. Simply, let me say one small interesting line. Please be careful. Right? The purpose of this problem, I'm repeating now. The purpose of this problem is going to be how to solve this series. Please be careful. The purpose of this problem is going to be how to solve this series. Right? Until here common. Right? So do k times, substitute the k value, you will get one series, that is okay. But how to solve this series? Can you say what is this series? Log 2, log 4, log 6, log 8 and so on, log n. So I think how to solve this series? If at all, only even numbers, that is the reason problem came. Only odd numbers, then also maybe problem will come. If all are there, even number, odd numbers are there, nothing there in that. Right? Even number, odd number is there, what is the answer? Log 1, log 2, log 3 and so on, log n, which is nothing but log n factorial. It is very simple. Only even there problem will come. Only odd there problem will come. How to solve that one? That is the purpose of this. Even numbers I solve. Right? So odd numbers also you can solve. Some people are asking how to solve odd number. No requirement of another procedure. From the total, remove even numbers. You will get odd numbers. If you know how to solve even numbers, you know how to solve odd number also. What is it? From total, remove even number story. You will get odd number. So total also you know how to solve. Even also you know how to solve. Odd automatically, even you know means odd also you know. So even series how to solve in terms of log, that is the purpose. Because of everyone is even number, 2 into something you can write. Because of the log mn formula, log m plus log n. Next one, log 2 is common, log 2 n by 2 times. Remaining all this series. Now it became normal series. Log 1, log 2, log 3, it became normal series, which is nothing but factorial. See, 1, 2, 3 and so on, n by 2. Which is nothing but n by 2 factorial. Its upper bound is going to be n by 2 whole power n by 2. Right? This can be written as big O of n log n. Right? So, to this problem, what is the problem here? See this. This is the problem. Tn is equal to Tn minus 2 plus log n. Answer of this problem is going to be big O of n log n. Right? This is the answer. Upper bound is going to be big O of n log n. Now one more thing. What is the k value to this problem? To this problem, what is the k value? K value to this problem n by 2. Some people are asking, to this problem k value n by 2 how? You may ask that. In the previous all problem, always you are subtracting 1, 1, 1, 1. You only say from 100 rupees if you subtract every time 1, 1, 1, 1. Right? To get the 99 times you have to subtract. From the 100, right, if you keep on subtracting 1, 1, 1, if you do 99 times, 99 will be eliminated. Lastly, 1 left out. So, previously, termination condition k value is going to be n minus 1 because always you are subtracting 1. You want 1 finally, n minus 1 times you have to do. But here, always you are subtracting 2. If you subtract always 2, how many times will come? N by 2 times. From the n, always 2 going on. Right? How many times you have to do? N by 2 times. From the n, always 1 going. N by 1 means approximately n. Right? From the n, always 3 going. 3 subtracting. N by 3. Always here 2 going. N by 2. Always if I subtract 3, n by 3. Right? Final answer is going to be log n log n. Some people are asking, sir, how this is n log n? You may say that n by 2 log n by 2. What is the answer? N by 2 into log n by 2 can be written as log n minus log 2. Which is nothing but log 2 is going to be constant, remove this n by 2, 2 is a constant, remove, so n log n. Comparing n by 2, log n by 2 is bigger, so n by 2 log n by 2 I took approximately this is equal to big O of n log n. Right? It will be the fourth problem. Please check, 3 times you do as usual. Afterwards in the third step, please get to know, is it in terms of 3 or not? If it is okay, right? Then go k times, k, find the k value, you will get one series, try to solve. In every problem one series will come, please remember it, because those may come in the exam. In the exam also no need to do research like that. No need to stuck also. You may stuck now because the first time you are doing, right? But when you repeat many times in the examination, you may not stuck, right? Fine. Let's see the next problem. 4 examples are over. I think it is the 5th example. Example 5. See, similar, almost similar thing, right? Let's start. Tn is equal to Tn is equal to 2 if n is equal to 0. Tn is equal to 2 if n is equal to 0. Otherwise, T n minus 2 plus n square if n greater than 0. So this is the one more problem, right? Let's see the answer for this. Similar, so that's the advantage with the any method, right? Same story will happen. The only thing is problem to problem, minor changes are there. Can you help Problem to problem, what will happen? Most probably in this method, maybe different series will come, right? Let's see anyhow. So I think else part only important. Can you read the else part? Tn is equal to Tn minus 2 plus n square, right? This is the recurrence relation. So let me substitute 3 times. So the first time substitution, Tn is equal to T n minus 2 plus n square. That is the first time. Tn is equal to Tn minus 2 plus n square. If you think you are not comfortable with this recurrence relation, substitute the right numerical value. Substitute now. T10 is equal to T8 plus 10 square. Next one, T25 is equal to T23 plus 25 square. Right, like that. Right. So if you are okay, Tn is equal to Tn minus 2 plus n square. One time substitution is over. See the second time. Tn minus 2 is equal to Tn minus 4 plus whatever is there whole square. If at all n is there, n square, n minus 2 is there, n minus 2 whole square. Because of this one is k, right? This one is as it is. Next one, let me substitute once again now. T n minus 6 plus n minus 4 whole square plus n minus 2 whole square plus n square. Right? Like this. Please check it 3 times I done, 3 non-recursive terms will came. Right? I think this is the current status. Let's see now. After 3 rounds over, what is the next step? Third round. 3 steps are over. See the third step. Right? In the third step, can you help in how many rounds you done? 3 steps. Because of you done 3 steps, answer should be in terms of 3. How? Let me check. 3 times I done. Answer should be in terms of 3. Then what is the answer? 6 there. But 3 times I done. 2 into 3, 6. Some people are asking why 2 into 3. You only say every time 2 subtracting. Right? First time 2 subtracted. 2 into 1. Second time, right, 1 more 2 subtracted, 2 into 2. Third time, 1 more 2 subtract, 2 into 3. Because of every time double you are subtracting, so double will come. Can you help? It is a 6 means minus 2, 4. It is a 4 means minus 2, 2. It is a 2 means minus 2, so 0 maybe, right, like that. So, if anyone having small doubt also, same thing will happening in the 2 times also. 2 times I done 2 into 2, it is a 4. 4 means it is a 2. 2 means it is a 0. 1 time also it is a 2 into 1, right? Minus 2. So 0 will come, right? Like that. So if you are comfortable, let's go to the next one. K times you do. Do K time. What is the answer? This will become T, right? N minus, what is the answer? 2 into K. If you do 3 times, 2 into 3. If you do K time, 2 into K plus, what is the answer? N minus 2K minus 2 whole square. What is the next one? N minus 2K minus 4 whole square. Right? And so on. And so on. Plus n square. Right? This will goes to, can you help after completion of this one? What is the answer? Termination condition. Let me write. N minus 2K is equal to, same termination condition like previous one. N minus 2K is equal to 0. N is equal to 2K. K is equal to n by 2. If you subtract always 2, 2, 2, right? N by 2 times you have to do. K value is n by 2. So this K is nothing but how many times I should do, so the termination condition will come. I am repeating now. This K is nothing but, right? To get the termination condition, how many times you have to substitute? Because of every time 2 subtracting, right? K time where K is n by 2, right? Replace K by n by 2. This will become T of n minus 2 into K is n by 2. This will become n minus 2 into n by 2 minus 2 whole square. right? It will continue like this one, n minus 2 into n by 2 minus 4, right? And so on, lastly n square, right? Simplify now. Every problem is similar, small adjustment. In every problem, one series will come, we have to solve it. This will become 2 cancel, n minus n 0. Next one, 2 cancel, right? N minus n cancel. So what is the answer? Right? I think it will become, what is the answer? 2 square. See this one, 2 cancel, this will become minus n plus 2. N minus n cancel plus 2 whole square, 2 square. Next one, 4 square. Next one, 6 square, because of 2 difference, 8 square, and so on. Lastly, what is the answer? N square. Right? N square. So now can help me, what is the T of 0? See the termination, 2 there, 2 plus. Right? It is the 2 plus, 2 square plus, 4 square plus, 6 square plus, 8 square plus, and so on. Lastly, n square. Now the question is going to be, right? In this problem, we have to learn this only, how to solve this series. Right? This is not part of the series. If at all possible, you can add this also. There is no objection at all. Whether you add this or not, it's up to you. But this series, right? This series, how to solve, let's see now. In this problem, our goal is how to solve this series. I think if you observe clearly, what is the answer? 2 square, 4 square, 6 square, 8 square. See this one. Some people are asking, sir, what is there in that? Sum of n natural number squares. No. It is not sum of n natural number square. It is sum of even number squares. It is not sum of n natural number square. It is sum of even number square. See, 2 square, 4 square, 6 square, 8 square, and so on n square. It is sum of even number squares. Please be careful. How to solve? I am explaining now. I have done many times. Listen, this series how to solve, right? If anyone solve this problem first time, right? So at this place you may stuck. If anyone try to solve this problem first time, you may stop here. You don't know how to solve this series. When I am doing first time, I also got the same problem. In the previous problem, if anyone try to solve the previous problem, in that series you may stuck. Stuck is nothing but you may take some time. First time, more time. Next time, right? Half time. Next time, right? Very less time. Please be careful. When first time is always difficult. In this problem, this is the only thing which I want to explain. Right? I am starting now. See this one. I also face a lot of difficulty starting. Most probably you will also face the difficulty. Right? So see how to solve this one. It is sum of even number squares. Even number squares. See the answer? 2 plus. 2 plus. But one thing I want to ask you, because of you only saying that these all are even numbers, every even number can be written as, right? Like this one, 2 into something, 2 into 1 whole square. Next one, 2 into 2 whole square. Next one, 2 into 3 whole square. When you say it is an even number, immediately how to remember, every even number can be written as 2 into something. Please be careful. 2 into 4 whole square. You only saying even number. Even number means immediately how to remember this one. 2 into something you can write. So I done this. Now this will goes to 2 plus. Because of it, every even number can be written as 2 into something. I think everywhere this is common. Everywhere this is common. Please be careful. So what is the common thing? 2 square common. Remaining 1 square, 2 square, 3 square, 4 square, and so on. Lastly, n by 2 whole square. Some people are asking, sir, how n by 2 whole square? This one. This is covering all natural number. This is covering all natural number. You only say these are even terms. These are even terms only. You are covering all natural number. So what is the answer? I am converting sum of, right? Sum of n by 2 natural number, n by 2 even number square, right? I convert into sum of n natural number square n by 2 times. N by 2, everyone here n by 2 terms only there because all are even numbers. N by 2 terms only there, all are even numbers, right? The only thing is, here even number squares are there. Now I made here right? Sum of n natural number square, but in the place of n by 2. So even number 2, normal I converted. Here also squares there, even number square. Here normal number square. Everything, even odd, everything there. But one thing, here n by 2 terms are there, here also same. Here only even, here all are there. 2 square common. After making 2 square common, it became sum of n by 2 natural number squares came. Fine. I think this one everyone know how to solve. 2 plus 2 square into. What is the answer? Sum of n natural number square. What is the formula? N into n plus 1, 2n plus 1 by 6. Sum of n natural number square formula. N into n plus 1, 2n plus 1 by 6. But in the place of n here, n by 2. Here n by 2. What is the answer? N into n by 2 into. n plus 1, n by 2 plus 1. 2n plus 1, 2 into n by 2 plus 1 by 6. In the place of n, just keep n by 2. n into n plus 1 into 2n plus 1 by 6. Right? Next one. See this one, forget about small constant, n into n. What is the answer? Big O of n cube. The actual answer is this. This is the actual answer. Right? If it is there in the option, you take. If not there, you can write upper bound. Everyone know. This is the left side of the big O notation. This is the right side. Big O notation, left side is this one, right side is this one. So, left side bigger function is n cube, right side also bigger function is n cube. Big O of n cube you can write. Right? You can write omega of n cube also. Theta also you can write. Right? So, this is the actual answer. This is the actual answer. Upper bound is n cube I written, lower bound is n cube, theta of n cube. This problem, previous problem same, the only thing is series is changed. All will be similar. This is the example number 5. Right? Fine. To this problem, what is the answer? N cube. Theta of n cube or big O of n cube, whatever it is. Please learn if something new. 3 times you do, go k time, k value n by 2 substitute, you will get this series. Right? Sum of even number square series will come. How to solve? When you say even number, everything can be written 2 into something. Then you got sum of n by 2 natural number square. Formula is this one. Upper bound is n cube. Right? Let's go to the next problem. Right? Example 6. I think until now 5 problems are over. See the 6th problem. Tn is equal to 1 if n is equal to 1. Tn is equal to 1 if n is equal to 1. Otherwise 2tn by 2 plus n if n greater than 1. Right? This is also one more problem. Tn is equal to 1 if n is equal to 1, otherwise 2tn by 2 plus n. Right? How to solve? Let's check. So, everyone know else part only important. Let's read the else part. Tn is equal to 2tn by 2 plus n. Right? If anyone having small doubt also, you should be comfortable by yourself by substituting the numbers do. Can you help me know? T100 is equal to 2t100 by 2 means 50 plus 100. I am repeating once again. T50 is equal to 2t50 by 2 means 25 plus 50. Right? If you are okay, let me go for substitution. Tn is equal to 2tn by 2. Right? Plus n. Right? Those people who are not little bit comfortable also, let me read once again now. T500 is equal to 2t500 by 2 plus 500. If you are fine, can you help me now? Right? Tn is equal to 2tn by 2 plus n, it's okay. What about tn by 2? Tn if you are comfortable. What is the tn by 2? What is the answer? This tn by 2 is nothing but, see this one? This tn by 2 is nothing but, right? Try to remember in the place of n by 2. What is the answer? 2t, n place n by 2 here. Right? Now what is the answer? N by 2 square. Plus what is the answer? N is there here n by 2, here n only. So here n by 2 there, n by 2. So see this one, because of this one is k. Right? Outside 2 there, keep as it is. Because of tn by 2, 2t, n by 2 is there, he means n by 2 by 2. Plus n is there, n square, n by 2 there, n by 2, sorry, n is there, n here, n by 2 means n by 2. Next one, outside n is there, write as it is. If anyone having small doubt also in the substitution, please take care. Can you help me now? What is the T50? Those people who are troubling little bit also, see this one. T50 is equal to 2T50 by 2 plus 50. Right? So, same thing, same way I done. Right? So, here Tn by 2 is equal to 2T n by 2 by 2. See this one, here 50 there, 50 by 2. Here n by 2 there, 2T n by 2 by 2 plus n by 2 there, n by 2. See 50 there, here 50. Here 50 there, 50 by 2, same thing I done. Whatever is there, same. Now, let me simplify. Let me simplify now. And one more small thing I want to ask you. Those people who are doing this problem first time, they forgotten to keep bracket. Please be careful, bracket. Tn by 2 means this much big story came. Here, 2 into Tn by 2, same way, 2 into this one. If you don't keep bracket, problem will come. I am saying reason also. If anyone do this problem first time, you may do this mistake. What is that? Brackets you may not keep. If you don't keep bracket, problem will come. Please be careful. Let's simplify now. 2 into 2, 2 square, t, n by 2 square. Just multiply 2 into 2, 2 square, t n by 2 square, plus 2 into n by 2, 2 cancel n. Right? So, if you multiply 2, this one also, both you have to multiply, total bracket you have to multiply. So, after multiplying, this came, outside n is there, keep as it is. So, I am repeating once again now, if you do first time substitution, this one. If you do second time substitution, this one, if you simplify this, you will get, it is the second only, after simplifying you will get. Now, one more thing, while doing substitution method, you got 2 square, don't write 4, keep as it is. If necessary, we will do calculation also. If not necessary, right, if really required, that time we will do calculation. Whatever coming, please keep as it is. Right, you may be comfortable in the doing the calculation, lastly we can do. I simplified, I got this answer. Right? Some people want to write 2n. Right? If you want, you can write 2n after completion of the third step. So try to remember first step, second step, third step. While doing this, don't do any calculation. Don't write n plus n as 2n. Write as it is, whatever coming. Until 3 steps are over, write as it is. Don't do any calculation. 2 square coming, write 2 square only. Right, 4 square coming, right, 4 square only. Don't do any simplification. Right, you can do after third step is over, you can do. Until third step, please control. I think see this one. It is the first step, second step I done. After simplification, I got this. Now let me do the third step. I am doing the third step. Please be careful. This one I have to expand. Expand now. This one if you expand, what is the answer? 2t n by 2 square by 2, 2 cube plus what is the answer? N by 2 square. Whatever is there, same. So this is multiplied by whatever is here, 2 square. Outside whatever there, write as it is. Now simplify. If you simplify 2 square into 2, 2 cube t, n by 2 cube plus 2 square into n by 2 square. I think n, outside 2 n's are there. Outside 2n. It is the third. After third step is over, this is the answer. After third step, this is the answer. After second step, this is the answer. After first step, this is the answer. Sorry, after first step, this is the answer. After first step, this is the answer. After second step, this is the answer. Simplification is there. Right? Next one, after third step, this is the answer. Now let me give the interesting thing. Can you help in the first, when you done first time, you only say, one interesting point is coming, please take care. Until now, in any problem, this story not came. It is the first time coming, please take care. Right, first time coming, please take care. See, whenever substitution method is going on, right, first time one non-recursive term came, yes, right, whenever substitution method is going on, in every level, one non-recursive term will come. Substitution method is going on, in every round, one non-recursive term will come. It is a non-recursive term. Right, first time over, it is a non-recursive term came, right, second time is over, one more non-recursive term came. It is the first level non-recursive term, it is the second level. Try to remember, whenever substitution method is going on, every time one non-recursive, right, one non-recursive value will come, one non-recursive term will come. It is the first level non-recursive term, it is the second level non-recursive term. Try to remember, first level, second level, non-recursive term is same, indication that in this problem series not coming. Every time different coming. First level one non-recursive term, second level one more non-recursive term, third level one more, means different one. In every level different is coming, series going on. In every level same non-recursive term is coming, series not coming, same coming. Can you help me now? First level, second level non-recursive term is same or different? Same. Indication that every level same will come. Series not coming, same coming. If you want, you can check. Third level, one more non-recursive term came. In all the previous problem, if you observe, first level, second level, third level, right? Non-recursive term is different coming. Different coming means series coming. Different not coming, same coming means, I think series not coming. Please be careful. 3 times I done. This is the story. First level non-recursive term, second level non-recursive term, third level non-recursive term. So series not coming. First level, second level non-recursive term is same. Indication that same thing coming, series not coming. Right? If you want, you can check third level also same came. Now I think fine. So let me introduce one small line. In this problem, what you can learn? What you can learn? I think please be careful brackets. You have to keep this bracket. This bracket you have to keep. If you don't keep brackets, some problem may come. In this problem, please learn, right? So brackets you have to keep, and one more.
First level, second level non-recursive term is same. Series not coming, same is coming. Please be careful. And one more, 3 rounds over as usual. What is the meaning? After 3 rounds over, verify what is going on. But one thing, right? After 3 rounds over, whatever is there, it should be in terms of 3. Let me check. 3 rounds over. Whatever is available, it should be in terms of 3. Let me check here. 3 rounds over, 3 came here. 3 rounds over, 3 came here. Next one, 3 rounds over, 3 ends. 3 rounds over means it is the 3 here, it is the 3. Right? That is the reason I said to you, don't simplify. 2 cube, 2 cube. Whenever substitution method is going on, 2 cube there, don't write 8. Keep 2 cube only. After 3rd round over, if really required, you can simplify. 3 rounds over, 2 cube you got, here also 2 cube, 3 ends came. Now some people are asking, sir, is it right or wrong? Can you go to the second round also? It is second round. 2 rounds over, it should be in terms of 2. Let me check, it is the 2 square. It is the 2 square, 2 ends. Right? 1 round over. What is the answer? 2 power 1, 2 power 1, 1 n. I think that is fine. Now go to the next one. 3 rounds over, this is the story. Let's go k rounds. Go k round. What is the answer? It will become 2 power k t n by 2 power k plus n plus k times. So k. 3 rounds means 3 n's came. K rounds means kn will come. Next one more thing I want to ask you. One more thing, right? So I think after doing k time, this one came n by 2 power k. But one thing is to which k value so that it will become termination. Can you say to this problem what is the termination? N value 1, then answer is 1. I think 1 should come. This should be 1. Let me check here. N by 2 power k should be 1. Then only it will stop. This value should be 1. Then only it will stop. So n by 2 power k is equal to 1 means n is equal to 2 power k. Apply log. Log n base 2 is equal to log 2 power k base 2. So k is log n base 2. Replace k by log n base 2. Replace k by log n base 2. If you replace k by log n base 2, what is the answer? 2 power log n base 2. It is the t of 1. Replace k by 2 power log n base 2. It will become n cancel, 1 will become. If you want, you can verify. Right? See, k replaced by log n base 2. Some people are asking, sir, how it is 1? Let's check here. How it is 1? See this one. N by 2 power k. Right? Which will become n by 2 power log n base 2. Right? This one, n by, right? This n will go here, 2 will go here. What is the answer? N power log 2 base 2, which will become n by n. Right? Means 1. That is the 1. That's how this became 1. Next one. Can you help me one small line now? What is the k? Log n base 2. N into log n base 2. Finally, this will become, what is the 2 power log n base 2? N will come down, 2 will go up. N power log 2 base 2. The t of 1 is 1 plus n into log n base 2. This will become n power log 2 base 2 becomes n. Right? N plus n log n. Right? Which will goes to, what is the answer? This side bigger function n log n. I can write big O of n log. Theta also you can write because left side, right side, same function there, which is bigger. To this problem, answer is n log n. Take care. No series came. Can you help me in this problem? What are the new things? No series came. Why no series came? What is the reason? Every level, different non-recursive term is coming, series will come. Same coming, series is not coming. And one more, please careful about the brackets. Some people are asking, sir, why k value here, right? Why k value here log n? What is the reason? In this problem, always n divide by 2 by 2 by 2. If you always divide by 2 by 2 by 2, how many time? Log n time. If you always subtract 2, how many time? N by 2. If you always subtract 1, how many time? Right? N time. If you want to get 0, n time. If you want to get 1, n minus 1. Right? Initial 3 problems. Right? Always subtracting 1, k value approximately n. Because of you want finally 1, n minus 1. In the remaining problems, if you observe, always subtracting 2, n by 2. If you always subtract 3, n by 3. Here always divide by 2. If you always divide by 2, how many times you should do? Log n time. So, this problem k is log n base 2. Answer for this problem is n log n. Right? Which number? What is the problem number? Right? Problem number 6. Right? Let's go to the problem number 7. Problem number 7. See this also. Tn is equal to 1. If n is equal to 1. Tn is equal to 1 if n is equal to 1. Right? Next one. Tn is equal to Tn by 2, Tn is equal to Tn by 2 plus n, if n greater than 1, right? This is the recurrence relation. Tn is equal to 1 if n is equal to 1. Otherwise, Tn is equal to Tn by 2 plus n if n greater than 1. Let's start solve. I think everyone know second part only important. Can you read the second part? Tn is equal to Tn by 2 plus n. Can you help this problem, previous problem different. Previous problem 2Tn by 2 plus n, but here Tn by 2 plus n. Here 2 not there. In the previous problem 2 there, here 2 not there. Right? So what is the answer? Let's check. It is very simple also. Let me try. Tn is equal to Tn by 2 plus n. Right? That is the given problem. Can you help me? What is the Tn by 2? Same. What is the answer? Tn by 2 plus n there, n by 2 there, n by 2. Already n is there as it is. Because of this one is k. Let's do one more time. 3 times we have to do. Let me do one more time. It will become T n by 2 cube plus n by 2 square plus n by 2 plus n. This one as it is. This one n by 2. This one n by 2 square. So one more thing I want to ask. How many times you done? 3 times you done. 3 non-recursive terms came. Okay, one more interesting answer. 3 times you done. 3 non-recursive terms came. It's okay. But all came same or different? Different came. Different came. Means series coming. Some people are asking, sir, small differences. Please be careful. Please be careful. 3 times write as it is. Don't do any simplification. While doing this story, lastly you can do simplification. In the middle of the method, don't do simplification. 3 times you substitute blindly. Whatever coming, write as it is. Even though small difference, please write as it is. Right? Don't do any minimization in the middle of the procedure. Lastly, you can write upper bound. After getting the final answer, carefully listen. After getting final answer is, after getting final answer, it is not there in the option. It is not there in the option. You can write upper bound. You can write lower bound. Please be careful. In the middle, don't write upper bound. Don't write lower bound. In the final answer, whatever came, please check the final answer also. Don't write upper bound, lower bound. After getting final answer, please check in the option. In the option, final answer as it is not there. Then you can go for upper bound, lower bound. Don't go to the upper bound, lower bound every time. Right? Actual answer not there, then go to the upper bound, lower bound. Please be careful. Don't do anywhere asymptotic story. Right? Whenever actual thing not there, you can go for upper bound, lower bound. Right? Please be careful. So, I think 3 times I done. First level non-recursive term n came. Second level non-recursive term n by 2 came. Third level non-recursive n by 2 square. Can you help me now? First level, second level differ means series coming. Please be careful. First level, second level non-recursive term differ means series coming. So for clarification, see, first level, second level differ means third also will differ. One time they differ. They will differ every time because that is the meaning of recursion. Recursion means what? Always doing same thing. What is the meaning? So one time changes means every time will change. One time not change, every time will not change. That is the meaning of recursion. Recursion means doing the same thing every time. So first level, second level differ means every time it will differ. First level, second level not differ means every time not differ. Right? Fine. 3 times I done. This is the behavior. Right? Can you help me now? 3 times over. Answer should be in terms of 3. Let's check here. If you do 3 times, it is the 3. It is the 2. It is the 1. It is the 0. Right? Same way. 2 times. What is the answer? It is the 2. It is the 1. It is the 0. Next one. If it is the 1 time, right? It is the 1. Right? It is going to be 0. Because of you are really comfortable, let's do the same thing. Right? Let's do k time. If I do k time, what is the answer? T n by 2 power k. Right? This will become n by 2 power k minus 1. 1 less c. 3 means it is the 2. K means k minus 1. Next one. N by 2 power k minus 2. N by 2 power k minus 3. And so on. Lastly, n by 2 power 0. Right, next one. This will become, what is the answer? This should be termination. What is the termination? Please check yourself. I think 1. N by 2 power k is equal to 1. N is equal to 2 power k. Log n base 2 is equal to k. K is log n base 2. Right? This will become, what is the answer? T of 1. Right? This will become T of 1. That's fine. Now see this one, this entire story. Right? If you replace k by log n base 2, this is the story. right? Now let me write this entire thing. You can write, right? You can write in this order also, whatever you want you can write. Like this also you can write as it is, like this also you can write. Meaning is same, a plus b, b plus a, both are same, right? You can write as it is, you can write reverse order also. Let me write reverse order, n by 2 power 0, n by 2 power 1. I am writing reverse order. Both are same. Next one, n by 2 square and so on. What is the last one? N by 2 power, what is the k? Log n base 2. Log n base 2 minus 1. It is the k minus 1. K is log n base 2, right? Replace k by log n base 2, same thing. I written in the reverse order. Now can you help me? What is the T1? Can you say what is the T1? T1 is 1. So what I want to say indirectly, directly, see this one. What I want to say indirectly, this is always very small number will come. This is always very small number, right? See this one. N is equal to 1, 1. N is equal to 1, 1, right? N is equal to sometime, N is equal to 5, 3. N is equal to 3, 2. You will write whatever you want here. Please be careful. This is not that much important. Some termination required they will give. In exam, listen, in exam, whatever you will give, use it. Suppose in some examination what happened, they don't give any termination. In all the problems whatever I given until now, some termination I given, right? In some examination, while giving recurrence relation, they don't give any termination. What is the reason? They are not given any termination doesn't mean that termination not there. They want to say that, right, anything is okay, you take. But one thing, take in terms of constant. If they don't give termination condition, right, you take whatever you like in terms of constant. Some people are asking, in terms of constant means what? You can write, if n is equal to 10, right, answer 5. If n is equal to 3, answer 20. You write any constant. If constant elements are there, constant. Right, write anything. If they don't give any termination, it doesn't mean that termination not there. They want to say that termination is, right, termination is not the one which will decide the answer, right, because termination is anyhow constant only. Take anything, no problem. Here T1 is, right, n is equal to 1, 1, n is equal to 1, 5, n is equal to 1, 10, all will give same answer. All differ by small constant only. Write anything, whatever you want you can write. Sometimes in some examination, while giving recurrence relation, they don't give termination. That means, right, termination there, termination not there, anything, right, both will give similar answer. The only thing is, only for termination purpose, something required. You give whatever you want, no objection. 1 also you take, 2 also, everything okay, right, no objection. Now see the answer. I think if I do k value log n time, this is the one, right? Let me simplify. What is the T1? 1. If at all you only say T1 is 1, T1 is 1. If at all T1 is 10, write 10. What is there in that? If T1 is 20, write 20. But one thing, it should be constant. If they don't give, take some constant. That may be 1, 10, anything is okay. Next one, plus, see this one, plus n common. Remaining, let me write 1 by 2 whole power 0. Next one, 1 by 2 whole power 1, 1 by 2 whole square, and so on. Lastly, 1 by 2 whole power log n minus 1. Right? Next one, see this one, 1 plus n into this series you have to solve. Can you help me now? What is this series? A power 0, a power 1, a square, a cube, and so on. What is the answer? It is the GP series. In the GP series, how many terms are there? Log n term, because 0 to 9 means 10, 0 to 99 means 100, 0 to log n minus 1 means log n. This series contains log n terms. It is the GP series, where log n terms are there. Log n terms are there. Please be careful, right? What is the formula? In the GP series, log n terms are there. Sum of log n terms in the GP. What is the formula? What is the answer? A into, what is the A? 1 by 2 whole power 0 means 1. A into, next one more thing. A into GP series sum of n terms. What is the formula? Right? See this one. GP series sum of n terms formula is A into R power n minus 1 by R minus 1. This is the formula. If R is greater than 1, this is the story. If R is greater than 1, this is the story. Please be careful. If R is less than 1, what is the answer? A into 1 minus R power n by 1 minus R. Right? If R value less than 1. If R value is less than 1, this is the story. If R value is more than 1, this is the answer. Please be careful. Right? Can you help me now? What is the R value here? 1 by 2. 1 by 2 is less than 1. I think this is the formula. Right? Less than 1. This is the formula. So what is the answer? A into, what is the answer? 1 minus, right, R power n. R is 1 by 2 whole power. How many terms? Log n terms. By 1 minus R, 1 minus 1 by 2. Please be careful this formula. It's the GP, sum of log n terms in the GP series where R value less than 1. So formula A into 1 minus R power n by 1 minus R. Right? Please be careful. This will goes to 1 plus n into. This will goes to 1 plus n into. Can you help in what is the answer? You only say. What is the 1 by 2? Interesting answer is coming. Please see here. What is the 1 by 2? 1 by 2 is 0.5. 1 by 2 is 0.5. What is the 0.5 whole square? 0.25. 0.2 whole cube. Right? 0. Right? This one case. This one maybe. 1 by 2 is going to be 0.5. 0.5 whole square is 0.5. 0.25. Right? If I do once again whole square, what is the answer? 0.5, 0.25, 0.0625. What is the meaning? The meaning of this one is going to be, it is already less than 1. R value already less than 1. If anything is less than 1, if you square it, cube it, right? Value decreasing, 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 decreasing. You done almost like function time. See, if you do 4 times itself, this is the story. Right? If you do 4 times itself, this is the story. If you do many times, function times, if you do, this value becomes 0. Let me write now. This is nothing but, right? 1 minus 0. See this one. 1 by 2 is 0.5. If I do whole square, 0.25. If I do once again whole square, 0.0625. Decreasing, decreasing, decreasing. This will become almost like constant. Almost like 0. Right? 1 minus 0 by 1 minus 1 by 2 means 1 by 2. Please be careful to say this only. To say this story only, I given this problem. The only purpose of this one is going to be to say this formula. Sum of n terms in the GP series where R value less than 1. This is the formula. And one more. Because of it is R value is less than 1. If you square it, if you cube it, value decreasing. Because of you are doing so many times. Function means what? So many times you are doing. This value almost becomes 0. Right? This final answer, if you observe, what is the answer? 1 plus 2, right? 1 plus n into, what is the answer? This is becomes 1 by 1 by 1 by 2 means 2, which will become 2n, big O of n. Answer is big O of n. I am repeating once again now, this GP series if you solve, this GP series if you solve, please be careful. Is it GP series? One interesting point I want to say to you. Is it GP series? Yes. In the GP series, R value less than 1 or more than 1? Less than 1. Try to remember GP series where R value less than 1. If you solve this one, you will get constant. In GP series, if R value is less than 1, if you solve this one, you will get constant. Please be careful. That constant may be 2, maybe 3, some constant you will get. Right? This constant into n, final answer becomes n. Right? Answer becomes n. See this one. N is already outside. This entire thing became constant. That constant is 2. Now, I think from this problem, I want to say one small thing to you. Please listen. Right? Sum of n terms in the GP series, you know, 2 formulas are there. Less than 1, more than 1. Right? Sum of n terms in the GP series where R value is less than 1. Right? That formula, whatever there, if you substitute, if you simplify it, you will get some constant. Because already R value less than 1, right? It cannot be more than, right? It cannot be more than, right? More than constant. Please be careful. Now, last line I want to say to you. Please be careful. If you have a GP series where R value is less than 1, right? Then sum of n terms in the GP series where R value less than 1. If you substitute that formula, final answer whichever is coming, that is going to be constant. Which constant I don't know, depending upon what is that equation and all, right? Some constant you will get, that may be 2, that may be 5, that may be 1 lakh, some constant you will get. Remember this. If you don't want to remember like this one, right? At least remember that formula. Less than 1 formula, sum of n terms in the GP series, R value more than 1 formula, sum of n terms in the GP series. That is also okay. Next one, R value less than 1. Any GP series if you find out, total sum if you add, you will get 1 constant. So, 2 into constant, see this one, this n outside there, this will become 2 constant, finally answer is n. To say this point only, this story, right? At the GP series R value less than 1, right? 2 formulas are there, less than 1, this is the formula. And one more, less than 1 formula, this formula if you apply, you don't get more than constant. This entire value becomes constant. Take any GP series where R value is less than 1. Where R value is less than 1, take any GP series, right? This total will become constant. So, n into constant, finally n is the answer. To say that story, I given this problem. In every problem, whatever I covered so far, in every problem, something is there to learn. Otherwise, I may not give this. And one more, GATE exam is going to be very easy if you know basics. Basics, you should be clear, right? Basics, you are comfortable. Mostly GATE exam, you can handle. If you practice more, it will become more speed. If you practice less, less speed. Whatever you knows, whatever I knows, right? Everyone most probably knows all, right? The only thing is if you practice more, more fast will come. In GATE examination, not only giving correct answer, right? Because of a lot of competition there, you should give correct answer within less time also. That is possible, right? That is possible if you practice more, right? Fine. See the next problem. So what is the previous number? Previous number is, I think, 7. Let's go to the 8th problem. Example 8. Right, example 8. Let's see this one. Tn is equal to, right? Answer is going to be 2. Anything you can keep, right? If n is equal to 2. Otherwise, 7t n by 2 plus n square. If n greater than 2. Some termination. If they don't keep also, take some constant here. Right? Some constant element, some constant. Right? Fine. So, Tn is equal to, major thing is Tn is equal to 7tn by 2 plus n square. Right? So, let me write. Tn is equal to 7tn by 2 plus n square. 70n by 2 plus n square, right? Now let me do, please be careful, it's this one, 7 into tn by 2 plus n square. And before going to continue further, right, be comfortable with the problem. What is the meaning? Let's check here by giving numerical 7, right? T10 is equal to 70 10 by 2 plus 10 square. Next one, T25 is equal to 70 25 by 2 plus 25 square, right? Similar way, let me substitute. What is the Tn by 2? What is the answer? 7t n by 2 by 2 n by 2 square plus n there n square, n by 2 there n by 2 whole square. This is for this. For this is the story. Outside 7 there, keep as it is. Please be careful with the, right, this bracket. If you don't keep bracket, wrong answer will come. Plus n square outside as it is. Right, is equal to, so what is the answer? 7 square t n by 2 square plus 7 into, right, n by 2 whole square, right? And one more thing I want to ask you, don't do any simplification. Don't, as it is you write. If any cancellation is there, cancel. Cancellation not there, write as it is. Don't try to do any simplification until 3 rounds. If you try to do simplification, unnecessarily you are making problem complex. 7 square came, keep 7 square. Cancellation there, cancel. I am not saying that don't cancel and all. Cancellation there, cancel. But don't do unnecessary simplification. After 3 rounds over, do whatever you like. Right? See this one, 7 square tn by 2 square. Let's simplify. 7 square tn by 2 tn by 2 square, it's okay. 7 into this 7 multiply into. What is the answer? N by n square by 4. I think no cancellation there. Keep as it is. N square outside as it is. Right? This one is fine. Next one. This is, I think everything is fine now. Let me go to the, and one more thing I want to ask you. First round, second round, non-recursive term is same or different? First round, second round, non-recursive term is same or different? Right? Different means series coming. If anyone want to know which series, first round, second round, non-recursive term is different means series coming. If you want to know which series, right? If you want to know which series, right? You have to know one more round. That is the reason. Every substitution method problem, do minimum 3 rounds. Minimum 3. If you handle properly, 3 rounds enough. But don't do less than 3 rounds. It may create some trouble. 3 rounds. I think 2 rounds over. Don't simplify unnecessarily. Keep as it is. Let's go for one more round. Right? 7 square is 7 square as it is. It's okay. This one. What is the answer? 70 n by 2 square by 2 cube plus n there n square. N by 2 there, n by 2 whole square, n by 2 square there, n by 2 square whole square. Outside things are as it is. Simplify now. Simplify. If you simplify now, 7 square into 7, 7 cube, t n by 2 cube plus 7 square into n square by 4. What is the answer? 7 square into n square by 2 square means 4, 4 square. What is the series if you want to know? You have, right? After third round, everything is okay. Next one, 7 into n square by 4. Right, next one, what is the answer? N square. Right, like this. 3 rounds over, it is the current status. No need to simplify also. Let's see. 3 rounds over, it is the current status. Let's check. Let's check here. Make sure that everyone please be comfortable. What is going on? I will verify. What is going on? I will verify. Let's see. Right? It is the current status. What is the series here? Let's check. If you do 3 times, this is the case. Now, can you help me after 3 rounds over? What will you do? After 3 rounds over, right? In the third round, final answer. Please verify everything is there in terms of 3 or not. Right? 3 rounds over, final answer, whatever is there as of now. In terms of 3 there or not, I will verify. Let me verify. One thing is confirmed. First level, second level, non-recursive term differ means series came. Which series if you want to know? Let's check here. 3 rounds, right? 3 rounds over. In terms of 3 should be there. See this one? 3, 7 cube, 2 cube. I think in terms of 3. And one more. It is a 3 means it is a 2. Right? It is also 2. It is a 3 means, right? It is a 3, it's okay. It is the first term is 3 means, next one is in terms of 2, that's okay. Next one is in terms of 1, see 7 power 1, 4 power 1. I think this n square is common everywhere, right? This one here also. What is the answer? I think 7 square by 4 square, 7 power 1 by 4 power 1, this one, 7 by 4 whole power 0 maybe. Right? This is 7 by 4 whole power 1. This is going to be 7 by 4 whole square. This is the 3 means, this is the 2, it is the 2 means, it is the 1, it is the 1 means 0. I think n square may be common. I am thinking that almost you got the clarity. After 3 rounds over, please verify what is going on. I know that it is a series. Which series if you want to know, right? First, third round over, please verify. Still, if anyone not get the confirmation here, see the after second round also what happened. It is the second round answer. See this one, 7 square t n by 2 square. I think everywhere 2. It is the 2 means it is the 1. See 7 by 4 whole power 1. Right? It is going to be 7 by 4 whole power 0. Right? I think it is also working. N square common. This also. If you do 1 time, 7 power 1 t n by 2 power 1. Right? It is the 1 means it is a 0. 7 by 4 whole power 0. I am thinking that you almost got the clarity. Let's go for k rounds. If you go for k round, what is the answer? It will become 7 power k t n by 2 power k plus, can help you know. It is the 3 means, it is the 2. It is the k means, it is the k minus 1. But one thing, n square common. Let me make n square common. Remaining if you observe. What is the answer? Remaining if you observe. You can go from this side also. You can go from this side also. Right? Anything is okay. Both are correct. Right? Now I am going from this side. What is the answer? This will become 7 by 4 whole power 0. 7 by 4 whole power 1. And so on. What is the lastly? 7 by 4 whole power. You only say. It is the 3 means. It is the 2. It is the k means k minus 1. Right? K minus 1. I know some GP series is there. Reverse order I written. See this one. N square common. 7 by 4 whole power 0. 7 by 4 whole power 1 and so on. 7 by 4 whole power k minus 1. It is the 3 means. It is the 2. It is the k means k minus 1. Let's find out k value. What is the k value? How to find out? Same. N by 2 power k is equal to whatever termination is there, that one. What is the termination in the problem? N is equal to 2. 2 is the answer. N is equal to 2. Termination is 2. This will become, right, n by 2 power k is equal to 2. It will become n is equal to 2 into 2 power k. It will become 2 power k plus 1. Right? If you simplify this, log n base 2 is equal to, what is the answer? K plus 1 log n base 2. Finally, k is equal to log n base 2 minus 1. Right? So, k is log n base 2 minus 1. Substitute here 7 power log n base 2 minus 1. It will become t of 2. Right? Everyone, how some people are asking how this is 2? Same way. How this is 2? Right? If by keeping k, right? By n by 2 power k becomes 2. Finally, k becomes like this. K becomes like this one. Right? Everyone know. N by 2 power k is equal to 2. K becomes this one. If you replace k by log n base 2 minus 1, same 2 will come. If you want, you can verify. N square. Right? This series. Can you help me one small line now? Right? See, isn't that it is a power 0, a power 1, a square, a cube, everyone at the GP. It is the GP. In this GP, what is the R value? It is the GP, it's okay. In this GP, what is the R value? 7 by 4. Is it less than 1 or more than 1? It is the more than 1, right? I think R value more than 1. That formula. What is the answer? A into 1 into. Can you see how many terms are there? 0 to, right? K minus 1. What is the K value? We are already done. What is the K value? Log n base 2 minus 1. K value, see. K value this much. Right? So, K value is log n base to minus 1, right? Minus 1. Totally become log n base to minus 2. Right? Can you help me now? 0 to log n base to minus 2 terms. What is the meaning? Log n minus 1 terms. Right? Can you help me now? What is the formula? A into. Whole power 0 means 1. Next one, R power. What is the R power? 7 by 4. Whole power. How many terms? Log n base to minus 1. Minus 1 by R minus 1. What is the answer? 7 by 4 minus 1. This will become, so from now onward simplification only. See this one, 7 power log n base 2 by 7. Everyone now, a power, right? See this one, x power a minus b, nothing but x power a by, right? X power b same, 7 power log n by 7 power 1. What is the t of 2? Some constant there, 2 there, plus n square into, right? Solve this, simplify this one. If you simplify, forget about small constant, it will become 7 by 4 whole power log n. Forget about minus 1 plus 1. These all small things neglect. If you want, you can write as it is also. I want to give upper bound. When I came here, I want to give upper bound. Right? I'm trying to give the upper bound. Small constant neglect. Can you help me? This can be written as, right? 7 power log n base 2. Forget about small constant. This constant. This is also constant, right? Plus n square into. What is the answer? 7 power log n base 2 by 4 power log n base 2. Right? This can be written as 7 power log n base 2 plus n square into 7 power log n base 2 by everyone. Now this can be written as 4, right? 4 can be written as, right? N will come down, 4 will go up. It will become n power log 4 base 2, n square cancel. Finally, what is the answer? This is becomes 2 into 7 power log n base 2. This will become, forget about 2 constant, n power log 7 base 2. Right? This finally become, everyone log 8 base 2 is going to be 3. Right? Log 7 base 2 is 2.81. It will become big O of n power 2.81. This is the answer. Answer is finally n power log 7 base 2. Log 8 base 2 is 3. Log 7 base 2 2.81. I written 2.81. The answer of this problem is going to be n power log 7 base 2, which is nothing but n power 2.81. To this problem. Right, to this problem, answer finally. What is the answer? Big O of n power log 7 base 2, which will become big O of n power 2.81. Right, this is the answer for this. What is the K value here? Because of you want 2 finally, log n base 2 minus 1. Always by 2, log n will come, log n base 2. Because of, right, if you come always by 2, if you come until 1, then log n base 2. Because of 2 itself, you are stopping 1 level less, log n base 2 minus 1. And one more, this GP series R value more than 1. This GP series R value more than 1. Then formula A into R power n minus 1 by R minus 1. Right? So, 0 to log n, then 0 to log n minus 1 means log n terms, but here 0 to log n minus 2 means log n minus 1 terms are there. R power n minus 1 by R minus 1. If we simplify, forget about small constant, major function I written 7 by 4 whole power log n. Small constant neglect. Right? This will become, right, 7 power log n by 4 power log n. Right? This 4 power log n can be written as n power log 4 base 2, which will become, right, n square. This is n square. N square cancel. So, 2 into 7 power log n base 2. Right? 2 constant neglect. So, n power log 7 base 2, 2.8. Please learn in this problem any small mistake also. Right? Please learn. And one more nice suggestion I want to give to you. See this one. After seeing this entire lecture, right? After seeing this entire lecture, every problem you take, you do your own. Every problem you take, you do your own, right? Whenever doubt there, right? First of all, listen all of them once. First of all, you listen all of them once, right? Afterwards, you start doing by yourself. At anywhere problem, then see the video once again. Do practice like that. Just practice like that 2 or 3 times, right? When you are comfortable with all these problem, After completion of this, try the new problem. Definitely you will be comfortable. If you start directly doing by yourself, definitely you may stuck somewhere, right? Because the first time you are doing. First listen all of them, little bit, right? Afterwards you start doing yourself, little bit doubt there, you can check. Like that 1 or 2 times you do, afterwards definitely you are comfortable. But one thing, don't by heart anything. At anywhere you have doubt, right? You can ask your friends, you can see the entire all the problems one more time. You can ask me also. 1 or 2 small doubt. Meaningfully you study 1 or 2 small doubt. Definitely your friends will help. I will also help. Many ways are there. Right? Fine. So this is example 8. Let's go for example 9. Right? Let's see this problem also. Tn is equal to I'm saying once again now Tn is equal to 6. Any termination conditioning 2 if n is equal to 2. 2Tn by 2 plus n log n if n greater than 2. This is the problem. Tn is equal to 2 if n is equal to 2. Right? Tn is equal to 2Tn by 2 plus n log n if n greater than 2. Right? It is a given problem. Right? Let's start. Same as it is. Let's start here. Right? Any base you can take, right? One base you can take to the entire problem. There is no objection. Right? So let's start now. I'm doing one by one. See, Tn is equal to 2Tn by 2 plus n log n base 2. This is the, if anyone having small doubt also, by substituting numerical value you can try here. T50 is equal to 250 by 2 plus 50 log 50 base 2. Next one, T25 is equal to 2T25 by 2 plus 25 log 25 base 2. Right, like that. Similarly, let's start. What is the Tn by 2? 2 is outside as it is. This can be written as 2T n by 2 by 2 n by 2 square plus n there n log n by 2 there n by 2 log n by 2 outside n log n. If you simplify this, 2 square T n by 2 square plus 2 into n by 2 n log n by 2 plus, right, this 2 n by 2 2 cancel n, right? So n log n by 2 outside anyhow n log n there. This n log n came like this. After simplification this one is given. 2 times I done this is. And one more thing I want to ask you. See this one. First level non-recursive term n log n. Second level non-recursive term n log n by 2. Some difference there. Some difference there means series coming. Which series if you want to know? Let's go for one more round. It will become, right, let's do one more round. 2 square. 2T n by 2 square by 2 2 cube plus n there n log n. Here n by 4 there. N by 2 square log n by 2 square. Outside things whatever they write. N log n by 2. One more. N log n. Let's simplify. 2 square into 2 cube. T. N by 2 cube. Simplify now. 2 square into n by 2 square. 2 square cancel. What is the answer? N log n by 2 square plus n log n by 2 power 1. Next. N log n by 2 power 0. Like that. Now can I help you? How many times you done? 3 times. You only say. If you do 3 times, right? It's total, I think total last line should be in terms of 3. Let's check here. 3 times if you do 3 here. It is also 3. It is a 3 means. It is a 2. It is a 2 means. It is a 1. It is a 1 means 0. And one more. N is common everywhere. You know very well series coming. This is the series. If you do 3 times 3 series, I think afterwards 2, afterwards 1, afterwards 0, n common. If you are comfortable, what about k time? K time, right? It will go 2 power k t n by 2 power k plus n common. What is the remaining? It is the k means it is the k minus 1. What is the answer? Log n by 2 power k minus 1. Log n by 2 power k minus 2. It is decreasing. Lastly, log n by 2 power 0. Find the k value, right? Next one, k value if you want to find n by 2 power k is equal to, depending upon what he is given, I think 2 termination, it is the 2. Right? If you not given, you can keep 1 also, 10 also, anything is okay. N by 2 power k is equal to some constant. Next one, n is equal to 2 into 2 power k, which will goes to n is equal to 2 power k plus 1. Right? Finally, log n base 2 is equal to, right, k plus 1. K is equal to log n base 2 minus 1. right? Replace now k value by log n base 2. 2 power log n base 2 minus 1, it is the t of 2 plus n into, right? This series, if you want, you can write in the reverse order also. Everything okay, whatever convenient you can do. So let me do in the reverse order. What is the answer? It will become log n by 2 power 0, log n by 2 power 1, log n by 2 square, log n by 2 power, what is the k? Log n minus 1, right? It is already minus 1, I think it will log n base to minus 2, right? Next one, this will become 2 power log n base 2 by 2, t of 2 is 2, some constant, n plus, right? This series let me solve. Everyone know. What is the answer? Log a by b formula. Log of a by b formula. What is the answer for this one? Log a by b formula. Let's check here. Log a minus log b. What is the answer? Log n minus log 2 power 0 base 2. It is the first. Same here also. Log n base 2 minus log 2 power 1 base 2. Any common base you can take, no objection. This one become log n minus log 2 power log n base 2 minus 2 base 2. This is for this, right? Simplify this. I am simplifying 2 power log n base 2. What is the answer? N by 2. It is the 2 plus n into, right? So let's see this one. What is the answer? Log n base 2 minus this one. Can you help me now? This is nothing but, what is the answer? Log 2 power 0 base 2. What is the answer? 0. This can be nothing but log n base 2 minus 0. This can be written as log n base 2 minus 1. This is nothing but log n base 2 minus 2. It will continue. Can you say what is the last one? Last one, if you see log n base 2 minus, this will become minus 2. Verify properly. Right? Fine. If you are comfortable, see the next story. N by 2 into 2. So n plus n into, right? This can be written as, what is the answer? Forget about, this can be written as, see from last side, what is the answer? Log n cancel. And one more, all are differ by 1 only. It is the log n, it is the minus 1, it is the minus 2, it is the minus 3. What is the last value? Log n cancel. What is the answer? 2. This is 2. What is the before? I think this one to this one, 1 less. It is the 2 means it is the 3, it is the 4, it is the 5, it is the 6, and so on. It is the log n, right? So let me write in the reverse order. If you write in the reverse order, it becomes 2 plus 3 plus 4 plus 5 plus and so on. What is the answer? Log n. 2 plus 3 plus 4 plus 5 plus and so on, log n. Right? This will goes to n plus n into, what is the answer? It is the sum of log n natural number. Forget about 1 less. 1 less, it's okay. It is sum of log n natural number. What is the formula? Sum of n natural number, n into n plus 1 by 2. It is the sum of log n natural number. What is the answer? Log n into log n plus 1 by 2. If 1 also there, this is the answer. 1 not there. So minus 1. What is there in that? Right? So if 1 also there, sum of log n natural number. So sum of log n natural numbers I written, because of 1 not there, minus 1. Right? This will goes to n plus n into, here what is the big function? Log n square into log n square. Forget about small thing. It will become n and n into log n square. N into log n square is bigger. Big O of n into log n square. It is the answer for this. To this problem, answer is going to be n into log n square. In every problem, some new series may came, right? And one more, this series I written reverse order. If you write reverse order, you only say it is the log n, it is the log n minus 1, it is the log n minus 2. Suppose it is the 100, it is the 99, 98, 97, 96 and so on. It is the 2. Reverse order if you see 2, 3, 4 and so on, log n. Reverse order I written. Right? So this is, I think, sum of log n natural number. But 1 is less, so minus 1. Right? Fine. This is the answer. And one more thing I want to say to you. First time you are doing any problem, guarantee it will trouble you. If anyone saying that, sir, this problem troubling, because it is really trouble you, that is the reason I explained. If it don't trouble, why I will explain these many problems. First listen all of them one time. Right? Afterwards do yourself. Anywhere stuck. Right? Please see the notes. Do like the 2 or 3 times, definitely you are comfortable. right? To this problem answer is n into log n square. And one more, left side, right side, bigger function is same. You can write theta also. Small constants only I neglected. Functions I didn't neglected. Small things only I neglected. Left side, right side, bigger function same. Theta also possible. To this problem answer is n into log n square. Right? This is the problem. 2t by 2 plus n log n. See this one. And one more. This problem we are already done. Right? But log n not there. Only n is there. Only n there. Answer becomes n log n. Because of, right, log n is there. Right? Answer became n into log n square. Little extra key. Same problem. Without log n we tried. N log n. Right? With log n also we tried. N into log n square k. Right? Fine. Anyhow. So it is the 9th problem. Right? Let's go to the one more problem. Example 10. Example 10. Let's see. Tn is equal to 2 if n is equal to 2. Otherwise root n, t root n plus n if n greater than 2. Tn is equal to 2 if n is equal to 2. Tn is equal to root n, t root n plus n if n greater than 2. Right. This is a problem. And one more thing before going to start it. It may trouble you. Right. Try to remember there is no complex problem. There is no easy problem. This is the one method. Right. Some people are thinking that, sir, it is a complex one. No. No complex, no easy. Right. This is one method. Right. So whenever you say it is a method, same procedure you have to do. Same procedure. The only thing is, one time may be subtraction. In one problem, subtraction. In one problem may be division. Now in this problem may be root. Because of root normally we don't use again and again. Right? Calculations may be something trouble you. Other than this, nothing there. Method you are following means all are similar. Right? Somewhere calculations are easy, somewhere calculations are difficult. Plus, right? Normally minus and division we done many times. That is the reason very easy. Root operation we are doing, it may be looking like little bit complex. Right? I will try. If any new series, please learn what is there in that. Right? Let's start now. Before going to start, right? Simply first of all, be comfortable with this problem. Let me check. Tn is equal to root n, t root n plus n. Those people who are having little doubt also, let's substitute numerical value. What is the answer? T100 is equal to root 100 t root 100 plus 100. Same way, right? T25 is equal to root 25 t root 25 plus 25. Like that we have to do. Let me try. Calculations only will trouble. Other than this, nothing there. See this one. Tn is equal to n power 1 by 2 t n power 1 by 2 plus n. Right? This is the Tn given. Let's do, right? What about t root n? Tn is this one. What is the Tn? Right? First time root, second time root, third time no root. Whatever is there, first time root, second time root, third time no root. Now, what about t root n? What is the answer? Whatever is there for that first time root, n power 1 by 2, once again root, n power 1 by 2 square. T, n power 1 by 2 square plus whatever there same, n power 1 by 2. This is, right, for this. This is the story. Outside already there, n power 1 by 2 already outside there. Plus n is as it is outside. Check anyone having doubt? Same thing I copy. See this one. N is there. First time root, second time root, third time no root. Next one. Already root there. Again root first time, again root second time, third time no root. Outside thing, this is as it is. This is also as it is. Now simplify. Simplify this one. N power 1 by 2 into n power 1 by 4. What is the answer? N power 1 by 2 into n power 1 by 4. It will become n power 1 by 2 plus 1 by 4. Right? This will become n power 4 here, 2 2's. 2 plus 1, which will goes to 3 by 4. Right? Let me write now. So it will become n power 3 by 2 square. Multiply. So n power 1 by 2 into n power 1 by 4, it will become n power 1 by 2 plus 1 by 2 square. It will become n power 3 by 2 square. T, n power 1 by 2 square plus multiply root n into root n, n. See root n into root n, right? N, what is there in that? Next one, plus n. Can you help First level, it is the first level non-recursive term, it is the second level non-recursive term. First level, second level non-recursive terms are same, means series not coming, same coming. First level, second level, same non-recursive terms are coming, means series not coming, same coming. Please be careful. So after 2 rounds, this is the story. Let me do third round. Right? Third round. Let me do this one. What is the answer? Whatever their root. N power 1 by 2 square there, if you keep root, n power 1 by 2 cube. T, n power 1 by 2 cube. Plus whatever there as it is, n power 1 by 2 square. For this is the story. Outside whatever there, write as it is. Right? This is same. N power 3 by 2 square. Now simplify. It will become n power 3 by 2 square into n power 1 by 2 cube. It will become n power 3 by 4 plus 1 by 8. It will become, what is the answer? N power 8 here. Right? 4 2s, 6 there, plus 1. It will become n power 7 by 8. Right? Let me write. N power 7 by 2 cube. T, n power 1 by 2 cube. Plus, right? I think n power 3 by 4 into n power 1 by 4. It will become n power 3 by 4 plus 1 by 4, which will become n power 4 by 4, means n. Outside 2 n's are there. So 3 times over. Please be careful with the calculation. If anyone thinking that, sir, I am not getting, calculate properly. See this one. Because of root there, calculations, some people are doing mistake. Right? Please do calculations properly. Can you help me know what is the answer of this one? N power 5 into n power 7. What is the answer? N power 5 into n power 7. What is the answer? It is not n power 35. N power 5 into n power 7. N power 5 plus 7. N power a into n power b. N power a plus b. Powers you have to add. Small calculation mistakes are going on. Please take care. If anyone thinking that this problem is complex, it is not complex. Calculations may be complex because we don't do root that much frequently. That is the reason some calculations mistakes are going on. Repeat this many times. If anything look like complex, do many times. Right? Do many times. So finally, after doing 3 times, this is the story. Some people are asking, after doing 3 times, what is happening? How I know? Right? I think everyone, it should be in terms of 3. Let me check. After doing 3 times, it should be in terms of 3. If you want, you can check 3n's k. Right? It is also 3k. It is also 3k. After doing 3 times, everywhere 3 came, right? This is also 2 cube. Some people are asking, what about this? What about? It should also be in terms of 3 only. What is the meaning? This 7 can be written as 2 cube minus 1. It should also, everything should be in terms of 3. Somehow it is. Somehow it is related to, in terms of 3 only. I think, see, 3 times over, 2 cube, 3 times. It should also be in terms of 3. I am thinking that it is going to be 2 cube minus 1. Some people are asking, what is the guarantee that it is the 2 cube minus 1? For confirmation purpose, go for 2 times. If you do 2 times, this is the story. 2 times I done, 2n's came. It is also 2. It is also 2. I think this is going to be 2 square minus 1 if you do 2 times. Right? I think it is looking like working. Same, if you do 1 time, what is the answer? 1n. It is also n power 1 by 2 power 1. This is also n power 1 by 2 power 1. But how this 1 came? What is the answer? Same. 1 time you done 2 power 1 minus 1. Same way. Right? That is the reason after 3 rounds over, please verify what is going on. Everything should be in terms of 3. I think for all the people I verified, I got to know. 3 times means 2 cube minus 1. 2 times means 2 square minus 1, like that. If you do k time, what is the answer? If you do k time, this will become n power. What is the answer? 2 power k minus 1 by 2 power k. It is t n power 1 by 2 power k plus kn. And one more, this should be termination. What is the answer? N power 1 by 2 power k is equal to, what is the answer? Termination, whatever there take. What is the termination? N is equal to 2, then answer is 2. 2. So I think apply log now. 1 by 2 power k log n base 2 is equal to 1. Apply log both the side. Right? I think 2 power k will go here. Log n base 2 is equal to 2 power k. Again apply. Log n base 2 is equal to k. K is log n. K is log n. Some people are asking, sir, why is k log n? You know very well. Always minus 2, n by 2. Always by 2, log n base 2. Always root, right? Log n. You know, in the first class or second class, same thing happened. Always you are dividing by 2, log n will come. Always you are doing n power 1 by 2, log n will come. What is there? K value becomes log n, right? Replace k by log n. This will become, let me simplify now. It will become 2 power k by, right? Sorry for this one, right? Let me simplify. N power this one, right? Simplify. 2 power k minus 1 by 2 power k. It will become n power. What is the answer? 1 minus 1 by 2 power k. It will become t of, what is the answer? This value, see this one, this is equal to 2. After replacing k by log n, same 2 will come. You verify yourself. Plus k becomes log n, n into log n. Right? What is this one? Let me simplify this also. This will become n by n power 1 by 2 power k. This is t of 2. Right? See in the problem what is the t of 2? I think 2 plus n into log n. Can you help me? What is this value? This value 2 you know. See this. From there only k came. If you want you can replace by k by log n, same thing will come. Right? This will become n by 2 into it is a 2 plus n log n. 2 cancel. What is the answer? N plus n log n. Finally answer theta of n log n. To this problem answer is n log n. What is the k value? Log n. Why? Always you are doing root. Is series coming or same coming? Same coming. Why? First level, second level, non-recursive term, same is coming. Third time also see, same came. If you go k time, this is the story. Final answer is going to be, right? N plus n log n. Answer is n log n. Left side, right side, same. So theta you can use. If anyone thinking that it is a difficult one, it is not difficult. Root operator is there. Calculations creating some trouble. Please practice it. It is okay. To me also initially difficult. I done many times. It became very easy. Substitution method purpose is solving recurrence relation. Recursive program is there. You know how to solve the recurrence relation now. Recursive program you know. Recurrence relation writing you know. Recurrence relation solving also you know. What are the advantage? Definitely in the next class you will see that. Let's complete the, right, solving the recurrence relation story. Afterwards how to use them, what is the use, you will see in further classes. To this problem answer is n log n.